Hello students, welcome to Educate. In the last class, we have discussed about the atomic model and we have discussed Till's Bohr's atomic model. In Bohr's atomic model, which was explained about the stability of atom, the arrangement of electron around the nucleus in an atom and the hydrogen spectrum. That was the phenomena explained by the Niels Bohr. Niels Bohr has explained about the phenomena which was not explained by the Rutherfords. That is, number one was the distribution of electron around the nucleus in an atom. Number two was the cause of stability of atoms, and third one was that he have explained about the hydrogen spectrum. So of that, about the stability of cause of stability of atom and the arrangement of electron around the nucleus in an atom, we have already discussed. Now we will discuss here about the line spectrum of hydrogen. About this point we will discuss, that is line spectrum, about the line spectrum of hydrogen. About this one we will discuss. Okay, so let's see here. Watch out here. Listen, here hydrogen, you know about that. In the nucleus, hydrogen, this is first cell, electron revolve on this one, electron, then after this one, and then after this one. Circular path. You already know the energy of electron in any cell, that is minus 2.18 into 10 power minus 18 upon n square. That is energy of electron in any cell. That is, so what happened? When you will find out the energy difference of energy between first cell and the second cell is large, then after the difference of energy between second cell and the third cell, that's decrease. So as we go away from the atoms, the difference of energy between the adjacent cell will decrease. And that was the question of AIPMT 2005. 2005, guys, when I am telling you, then you may consider that 2003 to 2007. Among these one, there was a question here that is you will have to watch out. That is in 2003 question was asked, or 2004 or 5 or 6 or 7. So during that course, there was a question that the difference of energy here between first one and second one, then second one and third one, then third one and fourth one, what's the arrangement of their energy? So that is here, as we move away from the nucleus, then the difference of energy between the adjacent cells, that decreases. So that keep in the mind here. Firstly, here it is also like this one. So first n equal to 1, n equal to 2 here. So here difference of energy is large. Then after here, again difference of energy decreased. Then after decreased, decreased. N equal to 1, that means that the first cell has been represented by a straight line here. So it is for n equal to 1, here n equal to 2, n equal to 3, n equal to 4, 5, 6 and infinity lastly. When hydrogen atom here, when energy will be provided in hydrogen, there be only one electron, this one. So energy n equal to 1 here, the energy revolving on this one, that is called ground state. When electron will revolve in the first cell, when the electron of hydrogen will revolve in first state, then first energy level, that is n equal to 1 here, that will be called a ground state. Ground state. When the energy will be provided to the atom, then if the energy having sufficient value will be provided to the hydrogen atom, then electron will jump into next energy level, that is the electron will jump into n equal to 2. So when electron here, so this when electron is revolving in this cell and energy provided to this hydrogen atom, then electron will jump into second cell, and that will be called first excited state. After that means here n equal to 2, n will be equal to 2, and electron after providing the energy, electron has been firstly jump into the next energy level, that is called, it will be called first excited state. If energy has been provided more, then maybe electron will go in third cell, then electron will jump into third cell, that will be called second excited state. In the same way, when too much energy will be provided to the hydrogen, then electron will jump into again next energy level, and that will be called third excited state. Electron revolves in the first cell in case of hydrogen, or hydrogen like species like He plus, that is called hydrogen like species. What is hydrogen like species? In hydrogen like species, the number of electron will be only one, but the number of proton in the nucleus will be more than one. That will be called hydrogen like species. Hydrogen like species means the number that the atom will possess only one electron, but more than one proton in the nucleus. That will be called hydrogen like species. Okay, so let's leave that right now. Right now we are discussing about the hydrogen. Same will be valid for hydrogen like species. So what is here? When electron revolves in the first n equal to 1, then that was called ground state. When this electron will, when energy will be provided to the hydrogen atom, then the electron present in the ground state, that will absorb that energy and will jump into the next energy level. Again, when energy will be provided, if the magnitude of energy will be provided to the hydrogen will be more, then electron will jump into again next energy level. Again, provided energy more, then electron will jump into the next energy level. So when energy will be provided to the hydrogen atom, then the electron present in the ground state will jump into the next energy level, which will be called first excited state, second excited state, third excited state, and so on. So, and therefore, when that electron, when the atom will release the energy, then this electron will fall into lower energy level. When energy will provide to the hydrogen, then electron present in the ground state, that will jump into their higher energy level or their next cell. And when the atom will release the energy, then the electron present in higher energy level, that will fall into lower energy level. Obviously here. So let's see here. So what happened here? When electron will fall from higher energy level to lower energy level, then the atom will release energy in the form of electromagnetic radiation. When electron will fall from higher energy level to lower energy level, then the electron will release energy in the form of electromagnetic radiation. That means since the energy of electron will decrease, so less amount of remaining amount of energy that will release in the form of electromagnetic radiation. Okay. Now it is obvious that when electron will fall from n equal to 2 to n equal to 1, so less amount of energy will release. Okay, less amount of energy will release. If electron will fall from n equal to 3 to n equal to 2, then greater amount of energy will release. If electron will release from n equal to 4 to n equal to 1, then again more amount of energy will release. So depending on from which energy level to which energy level electron is falling, that will be the energy of electron or the frequency of proton will be according to that, since there is a relationship between the energy and frequency and wavelength. About that we will discuss also here. So that is here. So one point you will have to keep in the mind that when energy will be provided to the atom, the electron present in ground state will jumps into the next energy level, and there will be the first stationary state will be called first excited state. The second stationary state will be called second excited state. In the same way, third excited state, fourth excited state, and so on. So this is here, and when the electron will fall from higher energy level to lower energy level, then the electron will emit energy in the form of electromagnetic radiation. Okay, now let's see here. Now let's see when the electron will fall from n equal to 2 to n equal to 1, that will be called first line of Lyman series. This one is first line of Lyman series. In the same way, when electron will fall from n equal to 3 to n equal to 1, that will be called second line of Lyman series. When electron will fall from n equal to 3 to n equal to 1, that will be called second line of Lyman series. So in the same way, third line of Lyman series, fourth line of Lyman series, fifth line of Lyman series, and so on. Now, when electron, okay, so what have you realized? The energy will be very high. Like when electron will form, the difference of energy, one point here, the difference of energy between n equal to 2 to n equal to 1, that is very high. So when electron will fall from n equal to 2 to n equal to 1, or n equal to 3 to n equal to 1, n equal to 4 to n equal to 1, when electron will fall in the n equal to 1 from any energy level, in the short you may keep in the mind that from any energy level, when electron falls into the first, when from any energy level, when the electron will fall in the n equal to 1 or in the first cell, then that will be the Lyman series. That will be called Lyman series. And here the energy of this radiation will be very high, because the decrease in energy of the electron will be also high. So when the decrease in energy of electron will be high, so the magnitude of energy released or the energy of radiation, the magnitude of energy released in the form of electromagnetic radiation will be also high, and that is for ultraviolet. Energy of ultraviolet lights are large. So of the Lyman series, these radiations fall into ultraviolet region. Then after this, when electron falls from n equal to any energy level, from any energy level to n equal to 2, when electron will fall from any energy level, any higher energy level to n equal to 2, then that series of that radiation will be called Balmer series. Balmer series. Okay, and what here about the Balmer series? About the Balmer series, what happened here? The energy compared to that of Lyman series, their energy will be less. So after ultraviolet, the energy of ultraviolet region are large, that of visible region are less compared to that of ultraviolet region. So the radiation falls under the Balmer series will comes under the visible. That will be, this one will be visible. Then after here, when electron will fall from n equal to here, from any state energy level to n equal to 3, then that will comes in Pascal series. When electron will fall from any energy level to n equal to 3, that will comes under Pascal series. In the same way, it is called first line of Pascal series. The same way, second line of Pascal series, third line of Pascal series, and so on. So watch out here, the energy of Pascal series, energy of the radiation, which is of comes under Pascal series, that are less. So energy that will be, when energy will be less, so there will, that will be comes under here infrared region. In the same way, there will be bracket series when electron from any energy level, when electron will fall into n equal to 4, then that will be comes under bracket series, and then after is Pfund series. Here not explained in detail so much. So same similar to this one, but very little here. Till here it is clear. Now when electron will comes from any energy level, like here, when electron will fall from to n equal to 4. Okay, again try. N equal to 3 here. Again, when electron will fall from n equal to 5 to n equal to 4. Again, n equal to 6 to n equal to 4. So it will be called first line of bracket series. So that will be first line of bracket series, it will be second line of bracket series, then again third line of bracket series, and so on. Okay, and when electron will comes from here to here, that will be called, so you watch out here, energy of this radiation will be too much less. Infrared region, it will also come under infrared region, and here that will be called Pfund series. That means when from any energy level, when electron will fall in n equal to 5, then that will comes under Pfund series, and that will be a type of infrared radiation. Okay, so here in the Lyman series, ultraviolet region, the radiations of the Lyman series will come under ultraviolet region, when in case of Lyman Pascal series, Balmer series. In case of Balmer series, the radiation will comes under visible region, and in case of Pascal, bracket, and Pfund series, they will comes under infrared region. Watch out here again one point. The energy of first line of Lyman series is less than that of the second line of Lyman series. Then after third line of Lyman series, fourth line of Lyman series, and so on. So first line of Lyman series, energy will be least. Among the Lyman series, the first line of Lyman series, the energy of the first line of Lyman series will be least. Okay. So write a question. This question was asked in the examination. So of NEET examination, this question was asked. So let's see, discuss about. Question is, firstly, read the question carefully, then after I tell you how to solve this question. And this question is too much easy. No difficulty there is. Now listen. It is asking wavelength of second line of Lamont series. So second line of Lamont series will be how? What? N equal to 1 here. When electron will fall from n equal to 2 to n equal to 1, that will be first line of Lamont series. And when electron will fall from n equal to 3 to n equal to 1, then when electron will fall from n equal to 3 to n equal to 1, then that will come under second line of Lamont series. Okay, so let's see here. So energy in the always energy emitted, that will be equal to here, decrease in energy will be equal to the decrease in energy of the electron will be equal to the energy of radiation. So how much there will be decrement in the energy of the electron, that will be equal to energy of radiation. That means when electron falls from n equal to 3 to n equal to 1, then the energy of electron will decrease. So the remaining amount of energy will emit in the form of electromagnetic radiation. So let's see firstly. So here n equal to 1 when will be there, n equal to 1. So that will be equal to here energy of the electron will be minus 2.18 into 10 minus 18 upon n equal to 1. So 1 square. That much. So that will be minus 2 point that much in joule per atom. Okay, for in one atom, that is for one atom. This one is now when electron equal to E equal to 3, then energy of electron will be minus 2.18 into 10 minus 18 that upon 3 square joule per atom. One point mention here for this one is okay. So now calculate here. So that is here, that will remain same, minus 2.18 into 10 minus 18, and so change in energy will be how much? Change in energy, that means E3 minus E1 or E1 minus E3. Change in energy of electron. I am here telling about the change in energy of electron. This one, that will be equal to final energy level. Guys, the change means always final minus initial. Whenever they will wherever there will be change, so change means final minus initial. Here change in energy of electron means when electron falls in n equal to 1, their energy minus when electron falls from n equal to 3. So that will be change in energy of electron. So that's change in energy E3 minus E1. that will equal to here 3 square 9. This here positive, so that means 9 minus 8, 8 upon 9. This one here, I hope this till here it's clear. So delta E, that means here, so delta E equal to here 9 minus 1, 8. That is energy released by the electron, and the energy released by the electron will be equal to the energy radiated from the atom. So the energy difference here is 1.92 into 10 minus 18. So the energy of radiation emitted when electron falls from n equal to 3 to n equal to 1, or the second line of Lyman series, will be 1.92 into 10 power minus 18. Okay, so that is here. I hope this one has been written. Now let's see here energy of radiation. So energy this one, so decrease it, so energy of radiation will be, so energy of radiation, this one is 1.92 into 10 minus 18. Okay, and for any wave, you know E equal to h nu, and E equal to, here already you know E equal to h nu, and C equal to nu lambda. Here nu is frequency of radiation, lambda is wavelength of radiation. About that, these two formulas well known. Maybe if here in 9th class also, I think you have studied. If not, then watch out here. And about that we will also use, there is a numerical, lots of numerical questions based on this relationship. So but keep in the mind here, velocity of light is equal to the frequency of that light into their wavelength. That is C equal to nu lambda. And another example, another formula is E equal to h nu. H is here called Planck's constant and nu is frequency of radiation, and the Planck's constant value is 6.6 into 10 to the power minus 34. Okay, joule second. So h equal to 6.6 into 10 to the power minus 34 joule second. Okay, so energy of that radiation is 1.92 into 10 to the power minus 18, because the decrease in energy of the electron is 1.92 into 10 to the power minus 18. So that's why energy of radiation, that will be 1.92 into 10 to the power minus 18. And you know, for any radiation, so equal to h nu, and nu equal to here, you can write c by lambda. So E equal to hc upon lambda, because wavelength of light is asking. So equal to hc upon lambda. So lambda will be equal to hc upon E. So that will be equal to here 6.6 into 10 to the minus 34 joule second. Velocity of light is 3 into 10 to the power 8 meter per second, that upon, okay, I am writing here, I am writing here, space is not so much. So 6.6 into 10 to the minus 34 joule second upon 3 to this one, upon energy is here 1.92 into 10 to the minus 18, 1.92 into 10 to the power minus 18, this much joule per atom, Okay, so here joule will cancel out, second inverse cancel out, meter per atom will be there, wavelength also comes in, SI unit will be meter. So now calculate 6.6 into 3 here. So I am rubbing this one. I hope this one clear. So it is here 6.6 into 3. So 19.8 into 10 to the power 34 minus 8, minus 34 and 8. So that 10 to the power minus 26. That is meter per atom. So wavelength of that radiation will be 1.98 into 10 to the power minus 27 meter per atom. Okay guys, now wave number, most frequently asked questions in the examination is about the wave number. What is wave number? Wave number is the number of waves in 1 centimeter or in 1 meter, depending on the unit chosen. Like here, if there is 1 centimeter length, in that length, how much waves will be there? What will be the number of waves? That will be called wave number. And wave number, so suppose here in 1 meter, suppose a wavelength, their wavelength is 2 into 10 to the minus 8 meter. So here when there will be 2 into 10 to the minus 8 meter, then number of wave will be 1. When the distance is 2 into 10 to the power minus 8 meter, then number of wave will be 1. So when there will be 1 meter distance, then number of wave will be 1 upon 2 into 10 to the power minus 8. Guys, watch out here this one carefully. Actually, by wave number, it is represented by nu bar, that equal to 1 by lambda. That's I am trying to fix in your mind. What is actually here? Suppose there is a radiation whose wavelength is 2 into 10 to the power minus 8. So when the total distance will be 2 into 10 to the power minus 8 meter, the number of wave will be 1. So when the distance will be 1 meter, so number of wave will be 1 upon 2 into 10 to the power minus 8. Or in other word, when the distance will be here lambda, then number of wave will be 1. So when distance will be 1 meter, then 1 upon lambda. So nu bar equal to 1 by lambda. So another type of question asking is calculate. Question asked from this topic are about the energy, wavelength, frequency and wave number. And more frequently asked question is about wave number and the energy. Even though about the lambda and frequency, that's not frequently asked, but about the wave number, that's frequently asked. So you should know that wave number, that is nu bar, that equal to 1 by lambda. So here lambda you have calculated. So wave number of the wave number during that radiation, wave number for the second line of Lyman series will be how much? 1 upon lambda. Lambda you have calculated 1.98 into 10 power minus 27 meter per atom. So that will be equal to wave number nu bar. That will be equal to here very easy, 1.98 into 10 power minus 27. That is meter. Yeah, so it will go above in the numerator. So meter inverse per atom. So what happened? How to solve these questions? Firstly, in the examination, like this type of calculation, if there be, and more frequently asked in the NEET examination. Yes, that is also asked. This type of question also asked in the IIT main examination. But the frequency of asking the question related to this one, related to this type of question, that is more in NEET examination. So now here, so consider this one 1.92 as 2. 1.92 as 2 you consider. So it will be 10 here, 10, so 10 here. So you make here, change like this. So that means here you are multiplying by 10. So that will be here 10 power minus 26. So 2 5 are 10. So that will be equal to 5 into 10 power minus 26. Okay. But in the examination, if so 5 into 10 power minus 6, this value is something less than 22. So this value should be something more than 5. So that will be equal to here some less than this one. So something more than, so 5 point something into 10 power minus 26. Watch out the option, in the option which value is something slightly greater than 5 into 10 power minus 26. First of all match the power. First of all match the power and then after go on the value. Okay guys, that was about this one, hydrogen spectrum, this one. Based on that there is also numerical question, about that we will discuss. Okay, so that was about the Niels Bohr. Then after came quantum mechanical model of atom. That is by Niels Bohr's atomic theory. Then after Niels Bohr's atomic theory has been also failed. And what's the reason for the failure of Niels Bohr's atomic theory? The predominant was that the Niels Bohr's atomic theory have not considered about the dual characteristic of particles. And second one was that the Niels Bohr's atomic theory has said that the electron in the Niels Bohr's atomic theory have proposed about the configuration of electron around the nucleus. So that means the Niels Bohr's atomic theory have stated that the electron around the nucleus revolves in a definite circular path. But after the discovery, after the theories of Heisenberg's uncertainty principle, after the Heisenberg's uncertainty principle, it can be stated the Heisenberg's uncertainty principle, it cannot be said that electron revolves in around this nucleus in a definite circular path. That could be stated only when both position and momentum of electron can be calculated precisely. But according to Heisenberg's principle, Heisenberg's uncertainty principle, the both position and momentum of electron cannot be calculated simultaneously within after a certain accuracy. So there will be some inaccuracy when both position, if there will be some accuracy in the calculation of, when there will be some accuracy in the calculation of the position of electron, then there will be some inaccuracy in the calculation of the momentum of electron. Okay, so let's discuss about the then after, that is about drawbacks of Bohr's atomic model. First drawback was that, okay, Niels Bohr have explained about the hydrogen, the spectrum of hydrogen or the hydrogen-like species, but about the spectrum, about the atomic spectrum of any other element, this theory was silent. So Niels Bohr's atomic theory has explained about the hydrogen spectrum or the spectrum of hydrogen or hydrogen-like species, but was silent about the atomic spectrum of other species. Second drawback was that the Niels Bohr's atomic theory have not considered about the dual characteristic of electron, that is particle characteristic and the wave characteristic. About that we will discuss here there also. That was about de Broglie's equation. De Broglie stated that when any object will be in a motion, then that object will possess the particle characteristic as well as the wave characteristic. About that, the Niels Bohr's atomic theory have not considered. And third one is that the statement of the Niels Bohr's atomic theory, that is, the electron revolves around the nucleus in a definite circular path, can be stated only when both position and momentum of electron could be calculated correctly, which is not possible according to Heisenberg's uncertainty principle. Okay, about those topics also we will discuss, but first of all, let's see about this. First one was These points. One more point is that about the arrangement of electron, it could be stated only when both position and momentum of electron can be calculated precisely. Okay, so that is here. So next point here is so about the particle characteristic here, wave associated with the electron that has been not explained by the Niels Bohr's atomic theory. Then after a new atomic theory has been proposed, and that was the quantum mechanical model. The new atomic model of the atom was proposed after the failure of Niels Bohr's atomic model, and that was quantum mechanical model. In the quantum mechanical model, the wave characteristic of electron was also considered, and in that one, in the quantum mechanical model, there was the concept of orbital. There was the concept of orbital. This one about the orbit, and there is the orbit. Orbit is the path along which the electron revolves. Orbit is orbit, or that is also called cell. That is the path along which the electron revolves around the nucleus. That is called orbit or the cell. And orbital is the region of space in which the probability of finding an electron is maximum. So here, what is here? So quantum mechanical model considered that we cannot calculate both position and momentum of electron simultaneously after a certain accuracy. So it has quantum mechanical model have stated about the probability of finding the electron. Probability of finding the electron. That is quantum mechanical model. So the region of a space where the probability of finding an electron will be maximum, that will be called orbital. So about those points we will discuss in detail, but in the next class. Okay, so it's all for this class. Thank you, Team Educate.